Hi, Fabio from Hopsworks here, and today we're going to be taking a look at feature views in Hopsworks. In the past couple of videos, we have been looking at feature groups. Feature groups, as we said, are containers for features, features which are not related to a specific model, but rather they are there available for people to use to build one or more different models, right? During the process of productionizing a model, there are different stages where a model needs access to feature data. You need it at the beginning when you're going to train the model. You need access to your training data. You need access when you are going to validate your model and test your model. You need access to the data when you are doing batch inference or real-time inference, right? So there are different stages in the model training and productionizing pipeline from which you need access to the feature data. One thing that is common across all these different steps is actually the set of features you need. All this information about the features you need, from which feature groups they're coming, and a bunch of other metadata that we're going to be taking a look in a second, as part in Hopsworks of what we call a feature view. Right? This feature view is essentially at eye level a selection of features from the feature store for a specific model. Right? You can define that in different ways. You can create them from the UI, but you can also create it from the API. And today we're going to be taking a look at what it means to create a feature view from the API, and what are the advantages and the nice features, nice functionalities that the Hopsworks API offer you. Right? So let's jump into our project here. I've created a bunch of different feature groups here. I am trying to build a model to predict whether or not the transaction is going to be fraudulent or not. So I have a bunch of features related to the profiles of the credit card holders, and the activity on the transactions and so on. And I want to create a model that uses these features, as I said, to predict whether or not the transaction is fraudulent or not. So let's just see how you can use this. You can use the Hopsworks API to build this functionality. So the first thing, as always, is to import the Hopsworks library and connect to the feature store using the Hopsworks library. After that, you need to select the feature groups that you need to include and you want to include into your feature view. And once you have done that, you go ahead and actually build the query that is going to basically select the features you want to include in the model. The query itself uses a DSL, uses an API that is really similar to what the pandas merging of data frame look like, right? So if you're familiar with pandas, you should pretty much be familiar with the Hopsworks API to select features. Here, essentially, I'm selecting a bunch of different features, and we're going to be talking in particular about the fraud label in a second from the transaction feature group. I'm going to select everything from the profiles except the credit card number and my event time. And I'm going to select everything from the profiles activity except the credit card number, the event time, and the standard deviation because it's empty or it's causing problems, so I don't want it in my model. So what happens when you use these APIs is that Hopsworks actually makes built up like what we call a point-in-time correct join. The problem here is that you are joining feature groups that have potentially different refresh rates at different frequency, right? You might the profiles activity is actually a streaming pipeline writing it, so it's coming in real time. You might have a batch feature group for like the profiles that gets updated every week or every month, and then you might have another like frequency for transactions and so on. So when you are joining events together, when you're joining features from different feature groups together, you want to make sure they are what we call point-in-time correct, right? And let me make you an example so it's more clear what we're talking about here, right? So let's take a look at these two feature groups. You have transaction feature group and they have the profiles feature group. I have a couple of different transactions from the same customer, and I have changes of the profile of the same customer, right? So at the 1st of January, the customer has an average spend of 14. Then at the 7th of January, it becomes 44, and then on the 14th of January, it becomes 78, right? So if I were to join the transactions with the feature group, with the profiles feature group, what will actually happen in a point-in-time correct join is the following, right? So the transaction on the 1st of January gets matched with the profiles at the 1st of January, so becomes 32.4, gets matched with the 14. The transaction on the 2nd of January, though, because there is no profile values for the 2nd of January, the most recent profile value is on the 1st of January, it gets matched with that value. It gets matched with essentially 14 again, right? And finally, on the 16th of January, the most recent profile profile data that we have available was generated on the 14th of January, so it gets matched with that value. So 10 and 78 gets matched together. So that's what we call a point-in-time correct join. And if you were to express this in a SQL statement, potentially across different multiple different feature groups, what you will find is that you will have a really complex SQL query to write, right? And this is going to be quite error-prone, and you're going to be spending a lot of time debugging it, right? So luckily for us, Hopsworks does that, and you can just basically keep using the Python API to have a consistent, correct point-in-time join. Finally, what we want to do is register this information, the feature selection that we have in the feature store, so that we can reuse the same information when we're going to go and generate training data, get batch data, and get inference data. To do so, what we're going to do is we're going to call this get or create feature view. Here we are providing the name and the version. We are providing the query object that we just generated, and we're also providing which of these features or columns in my query is going to be my my label. In this case, I have a single one, which is the fraud label. This is important because when I'm going to reuse this feature view object to retrieve batch data or to retrieve inference data, the feature store will not have access to the label, and so it's not going to try to return it to me, obviously, because that's what we are going to try to predict later on. Finally, I can apply what we call model-dependent transformation functions, right? So there are transformation functions like normalization of the data, one-hot encoding, and similar, where it makes sense to apply it only on the subset of data that you actually are using for training your model, right? So if we go back on top and we see this example, here we can see that the feature groups actually contain data for the profiles of all the users across all the countries, but for this specific model, we are only interested in training the model on the US customers, right? So I can't normalize the data at the feature group level because the normalization will apply to all my customers. I want to apply the normalization only on the US customer in this case for training my fraud detection model for the US, right? So what happens here is that when I'm creating a feature view, I can actually register a set of transformation functions that I want to apply to each and every feature. And these transformation functions, they will get applied when I'm going to go and generate training data. The same transformation function will be consistently applied in the case I am getting feature data. I'm getting feature data for batch inference or real-time inference, right? And if this is normalization, we're gonna, like Hopsworks is gonna take care of computing statistics and make sure that the same statistics like mean, max, and so on get applied across all these different operations I just mentioned, right? So I can go ahead and actually create this feature view, and I can actually go on the feature store and actually see it, right? I can open the feature view section, and here I can see all the features that are in my feature view. If there are transformation functions applied, from which feature group they're coming from, if the feature or if a specific column is my target, which one it is, and a bunch of more information, right? So here, for instance, I've generated already some training data, and we're going to be looking at generated training data in another video. I can see, I can have a diagram of where the feature view is retrieving data from, so I can basically track the lineage on my data. And I can add the different components that we have seen in other videos, like tags and so on, and keywords and so on. So this is actually, feature views in details, selection of features that I'm going to reuse across different operations for training my model, to do batch inference, and to do real-time inference. We're going to be taking a look at these 3 different operations in a separate video. And thank you for listening, and we'll catch on those videos.